Now we're ready to start talking about the different ways we can actually learn about causality. And we're going to start with one of the oldest and best ways of doing it, experiments. Now remember the definition of a unit level causal effect. It's the difference between your outcome when you're treated and your outcome when you're not treated, holding all of the variables fixed. So the easiest way to learn about unit level causal effects is to find two units who have every single variable exactly the same, okay, and except one of them is treated and one of them is not treated. Then you just look at the outcomes for the treated one, the outcome for the non-treated one, you take the difference, and you're done. That's the idea behind a controlled experiment. Now these are just the same things you see on TV infomercials where they're testing paper towels and they say, here we have two paper towels, identical stains, but this one is our brand and this one is that other brand, and look how much better we are. That's just a controlled experiment. It's a little more serious example. Here I have a picture of a plant growth chamber that they have in places like the Chicago Botanic Gardens, where they use to do controlled experiments on plants. So suppose you want to know the effects of higher CO2 levels on plant growth, for example. Well, what you can do is you've got two of these plant growth chambers. You take two genetically equivalent plants, put one in one chamber, one in the other. Then you set all the variables the same in both chambers using this control panel over here. You set things like the humidity level, the daylight level, etc., stuff like that. Except one variable you vary, the CO2 level. In one chamber you put it low, and in the other chamber you put it high. Everything else is the same. Then you wait for a while, and you measure plant growth. Okay? And since the plants are exactly the same and all the variables are the same, any differences in growth can solely be attributed to differences in the CO2 levels. So that's a controlled experiment. Well, with these kinds of controlled experiments, you can, in principle, just have two observations. One that's treated and one that's not treated. In practice, you may want to observe a little bit more just because there's measurement error in how you measure the outcomes or the treatment levels, CO2 for example. But as far as causality is concerned, you only need one variable to be treated, one unit to be treated, and one unit to not be treated. Okay. Now in social science, controlled experiments are basically impossible. And there are many reasons for this. The first being that measuring variables is very difficult in social science. So there are lots of things like ability and effort and intelligence that are very, very difficult to measure. And the idea behind a controlled experiment is to get two units that are exactly the same in all variables. But if you can't measure every variable, then how do you know whether two units are the same? Second, there are many, many, many variables that might matter in a social science setting. And even if you could measure every single one of them, you're probably not going to be able to find two people that are exactly identical in every way, except for you're going to treat one and you're going to treat the other. Basically impossible. And this is unlike in physical science like the plant growth chambers, where it's typically known that only a few variables will matter for these things. So basically controlled experiments are out. So what's the solution? The solution is to do randomized experiments, which is what we'll talk about next time.